All right, let's take a look at g of x equals x cubed, and then afterwards h of x equals the square root of x. And we're going to start with the domain. Remember, the domain is the set of all possible input values or x values. So what we want to do is we want to look at the points on our graph and see what x values correspond to points on the graph. So what we can do is first, let's look at this part to the right of the origin, this part up here. We can see that as we're projecting these points down, we end up with positive values of x. Now the thing is, you might be tempted to think that the graph stops somewhere around here, and the domain only goes up to maybe 3 or 4 or something. However, if we were to zoom out on this graph, it's increasing, but it's always going to still go to the right. This arrowhead tells us that it continues forever. And if we were to look at Desmos or some other place, and we were to zoom out super duper far, we would see that we would still have x values getting larger and larger and larger. Now I'm going to cheat a little bit, and I'm going to use a little bit of algebraic reasoning here, or numerical reasoning. We know that there are going to be points on the graph that have, for example, 10 as an x value, because we can take 10 and cube it. So I know that we're focusing today on reading information from a graph, but I'm going to just cheat a little bit because I think it's important for your own knowledge to know that this particular graph is going to continue going to the right forever. And so we will have all of the positive values of x in the domain. It's just difficult to see that from the graph because the graph goes up so steeply. We could draw the graph in a different way. We could kind of zoom out and we could kind of stretch out the x-axis to make things look a bit different. But this is just one example that's a little bit hard to do just by looking at it. Now let's look on the left-hand side of this graph. If we project those points onto the x-axis, we can see that we're going to end up getting the negative values. And because the graph does continue and it keeps going to the left, we will end up with all the negative values. And so the domain is going to include all the positive values, all the negative values, and it does include 0 because the origin is part of the graph. So the domain is going to include all real numbers, and so we can say the domain is the set of numbers x such that x is a real number. This is similar to the last example. The last example also had the domain being all real numbers. Let's move on and let's take a look at the range now. If we look at the range, then we want to take points and project them onto the y-axis. And so here I am projecting points. And I think we can see pretty easily that we're going to have all of the positive y values accounted for. And then if we look down below, we can see that we're also having the negative values accounted for. So if we look at the range, it includes the positives and the negatives and 0. And so the range is also going to be all real numbers, which we can write in set builder notation, the set of numbers y, such that y is a real number. Let's take a look at the other function now, h of x equals the square root of x, because the domain and range here will be different from what we saw in the previous example. Let's start with the domain. Remember, this is the set of x values. So if we look at our graph and we project the points onto the x-axis, we can see pretty easily that we're going to get all the positive values. And we do get 0 because this graph does include the origin. but we don't end up with any negative values. So the restriction that we have on the domain is that it only includes positive numbers or 0, doesn't include negative numbers. And we can write this algebraically by saying that x has to be greater than or equal to 0. All right, now let's talk about the range. Here we're looking for the set of possible y values. And so what we want to do is we want to take points and project them onto the y-axis, like this. And if we continue here, we're getting larger and larger values, but they're getting larger pretty slowly. And so we ask ourselves, are they going to stop at some point? Is maybe 4 or 5 the largest y value that we get, or will they keep going? Now it's difficult to see this based on the graph. So again, I'm going to cheat a little bit, and I'm going to use what we know about the function. This function is the square root of x. As we pick larger and larger values of x, like x equals 100 and x equals 10,000, we are going to continue to get larger and larger values of y. As x increases, the square root of x is going to continue to increase and get bigger and bigger and bigger. And so we will eventually end up with 5, because 5 is the square root of 25, and we will end up with 8, because 8 is the square root of 64. And if we keep going, we're going to end up with all of the positive values. So the range is going to include all of the positive numbers and also 0, but not the negative numbers. And the way that we express that is going to be the set of numbers y such that y is greater than or equal to 0. And that is the domain and the range of the square root of x. In the next video, we'll look at 2 more of the fundamental functions.